Hello, this is Mrs. Ward, and I am going to go over the classwork problems for Chapter 6.1, Law of Sines. So let's start with number one. I have this triangle, and the directions say use the law of sines to solve the triangles. If two solutions exist, find both solutions. So the first thing I'm going to do is I have angle A is 25 degrees, angle B is 60 degrees. I'm going to go ahead and find angle C first. So to do that, I know that three angles of a triangle have to add up to 180. So to find angle C, I'm going to say that's going to be 180 degrees minus the sum of 25 plus 60. And when I do that, I end up with 95 degrees. So that is going to be angle C. And I might want to write that in there. So there's 95 degrees. The next thing I'm going to do is I am going to use the law of sines, and the pair that I have is I have angle A and side A, so my proportion is going to be, and I believe Mrs. Kelm does her side over her angle, doesn't really matter. So I have 12 over sine of 25 degrees. To find side B, I'm going to use 60 degrees. This went a little crazy on me. So sine of 60 degrees, and I am going to want to find side B. And so I'm going to do this on my calculator. I'm going to show you how to do the first one, and then after that, just a few here and there. So I'm picking up my calculator, and I believe she talked about numerical sums. So I'm going to go to a graphing page. I'm going to hit menu. I'm going to go to algebra and numerical solve. And I have that end solve. So then I'm going to do my favorite button, the control divide. And I am going to put in 12 over the sine of 25 degrees. And probably the most important thing you're going to have to do for this is remember to hit the degree symbol, because your calculator is in radians. So if you don't hit this degree symbol, you're not going to get the right answer. I'm going to get out of that fraction, hit the equal sign, set up another fraction. Oopsie, set up another fraction. Not like that. And now I'm going to do, and I'm going to go ahead and use the letter B. And then my angle is going to be, that's 60 degrees. Making sure I put that degree symbol. And then remember, you get out of this, you hit comma, and then whatever letter you put here is the letter that you're going to put after that parentheses. So I'm going to do letter B. I'm going to hit enter, and I'm going to get side B to be 24.59. So side B is 24.59. And then I just want to show you a trick. To find side C, I'm going to go back to my calculator, but before I do that, I'm going to write my proportion. I'm still going to use this, the 12 over sine of 25 degrees. And now the angle is 95 degrees. Whoopsie, that's not 95. And I'm going to do C here. And so I'm going to find out what C is. On my calculator, you've already done all that work to type it in. So when I go to do it on my calculator, I'm just going to go up. So I'm going to hit the up arrow key so I can grab that whole thing, hit enter. And the only thing that's going to change, the only thing that changes from this proportion to this proportion is this angle here, 95. Yes, I know the letter changes, but I'm not going to bother changing that. So I'm going to hit my right arrow. So I'm hitting my right arrow to go in here, hit down, and I'm going to change this to 95 degrees. Put that there, delete that. So now I have 95 degrees. I know this should be really letter C, but it's really not worth my effort to change it, so I'm not going to change it. I'm going to hit enter. Whoopsie, that's not enter. Yes, that's what I listened to. I'm going to hit enter. And I get 28.2, and if I round correctly, that would be 28.29. and that's going to be side C. So just to do a quick check, I have all three sides, I have all three angles, so that triangle is solved. Now moving on to the next one, I am doing 5, which they give me my angles in degrees in minutes, so that's fine. So to find, let's find the missing angle. So I'm going to do 180 degrees minus 25 degrees 30 minutes plus 80 degrees 15 minutes. If the degrees and minutes, if you don't like those, then on your calculator you can take that 25 degrees 30 minutes and change it to degree decimal, and that'll give you 25.5 degrees. And then you can change the 80 degrees 15 minutes to degree decimal, and you're going to get 80.25 degrees. That might be easier to do it that way, honestly, than do this, because this you'd have to remember to do the degree symbol when you have 180. So when I did this, I did it, I end up with angle C is going to be 74 degrees 15 minutes. If you use the decimals, you're going to get 74.25. You get 74.25. Change that to degree minutes seconds, and then you'll get that 74 degrees 15 minutes. You should stay consistent with however they give you the problem. You should stay consistent with that. So I have angle C as being 74 degrees 15 minutes. My proportion, I'm going to use a proportion that's given to me first. So the opposite pair that's given to me is, I have B with side B, so that's going to be 2.8 over the sine of 25 degrees 30 minutes is equal to, and we'll look for A first, over the sine of 80 degrees 15 minutes. Again, if you change these to decimals up here, you're more than welcome to use those decimals here. When I solve this, when I do it on my calculator, I get 6.41. And then the others, then I'm going to go now find side C, sticking with this proportion, 2.8 over the sine of 25 degrees 30 minutes is equal to C over the sine of 74 degrees 15 minutes. When I do that work on my calculator, C ends up equaling 6.26. So that's just a matter of throwing in your calculator, doing the end solve. Number 7, they give me the angle A is 36 degrees, side A is 8, B is 5. I like drawing the triangle, and it doesn't matter how you draw the triangle, just label the triangle. A is going to be 36 degrees. Side A, which is going to be opposite, is 8. The side opposite is going to be 5. My first proportion that I'm going to set up is I have this opposite pair. I have 36 and 8, so I'm going to say 8 over the sine of 36 degrees is equal to, the only other side I have here is 5, so I'm going to put 5 here. And when I do that, I'm looking for angle B, but I'm going to have to write the sine of B, and I'm going to put a degree symbol there to remind me that I want to change it to degrees. And I'm going to have my calculator do that for me. So I'm going back to the calculator because this is the first time we've looked for an angle. I'm going to type in what I have. So I am going to do menu, algebra, numerical solve, making a fraction. I'm doing the side, which was 8 over my angle, which was sine of 36 degrees, making sure that I remember to put the degree symbol in. Getting out of that fraction, I'm going to hit equals, create another fraction. And this side, it has a length of 5, so I'm going to put a 5 in here. And then in the denominator, I'm going to put what it would be, which we said sine, and we'll use the letter B, and I'm just going to use lowercase b, but I want my answer in degrees, so I'm going to tell my calculator I want the answer in degrees by putting that degree symbol with B. And then I'm going to hit comma and just the letter B. So notice you have to put the degree symbol here when it's in the equation. You do not put it here. When I hit enter, I get 21 point rounding correct, well, 21.55 degrees. I rounded that to 21.6 because somewhere I was taught to always round angles to the 10th. So I am going to make this angle B. Angle B was going to be 21.6 degrees. So if I put that in here, this is something that we solved for, so that's 21.6 degrees. Now, since I have two angles, I can find my third angle, so I'm going to take 180, subtract 36 plus 21.6. And when I do that, and this is how I'm finding angle C, when I do that, C ends up equaling 122.4 degrees. Then to find this is 122.4 degrees. To find side C, I'm going to use that 8 over the sine of 36 degrees is equal to, and now I'm going to put C over the sine of 122.4 degrees. So if I'm going up and grabbing that what I did on my calculator before, I'm going to have to change two things because this fraction completely changes. So I'm going to go up and grab that. The first part of the equation stays the same. So this 8 over the sine of 36 stays exactly the same. This is now what I'm looking for. So I can call this C if I want. The angle that I have is 122.4. And since I changed this letter C, I'm going to have to remember to change this C. I could have left it B, up to you. And I end up with 11.49, and that's going to be my side C is 11.49. So now I have all three sides, I have all three angles, and that triangle is solved. Going to do number 9, same thing. I'm going to draw my triangle first. A, B, C. A is 102.4 degrees. B, I don't know. C is 16.7 degrees. Side A is 21.6. So the opposite pair I have is this A. So I'm going to say 21.6 over the sine of 102.4 degrees is equal to, and then I only have angle C, so I'm going to say sine of 16.7 degrees and look for side C. And then when I do that, when I put that in my calculator, I end up with C equaling 6.36, and that's a side, so that's just going to be 6.36. Now to find angle B, I take 180, subtract 102.4 plus 16.7, and when I do all that, B ends up equaling 60.9 degrees. So to find side B, I'm going to take that 21.6 over the sine of 102.4, and I'm going to look for side B, and that's over the sine of 60.9 degrees. When I do that, B ends up equaling 19.32. And then sometimes I like to take what I call a reality check. And what that means is the opposite angle, the side opposite the largest angle should be the largest side. So my 102 degrees is the largest angle, and it's opposite of 21.6. That 21.6 has to be larger than the other two sides, which it is. And it should make sense that this side 6.36 is really small because this angle 16.7 is small compared to that 102. My triangle, not drawn to scale, didn't even worry about drawing it to scale. Just want to make sure that I have that. That's helping me find that opposite pair and line everything up. Number 12, again, we have the degrees and minutes. Again, if you don't want to deal with those, then you can change them to degree decimals. That is up to you. Just make sure that when you find your angles that you put them back into degrees, minutes, seconds. So here we're going to do ABC. Angle B is 2 degrees, 45 minutes. Side B is 6.2. Side C is 5.8. So I have two sides, so I'm going to look for angle C first. So I'm going to say 6.2 over the sine of 2 degrees 45 minutes. Again, if you don't want to deal with that in your calculator, you're going to change that to degree decimals. And I'm going to do 5.8 over the sine of C degrees. And when I do that, I get C to equal, on my calculator first, I got 2.57 degrees. And then I did the degree minutes seconds, and that ended up being 2 degrees 34 minutes. And that's angle C. Then to find, I took 180, made sure I put the degree symbol, 2 degrees 45 minutes plus 2 degrees 34 minutes. And when I did that, I ended up, and this is trying to find angle BA. When I did that, I ended up with 174 degrees 41 minutes. I didn't write in what I found, and that's what threw me off. This ended up being 2 degrees 34 minutes. And then this ended up being 174 degrees 41 minutes. And now I have to find side A. So I'm going to take 6.2 over the sine of 2 degrees 45 minutes is equal to A over the sine of 174 degrees 41 minutes. When I do that on my calculator, I end up with 32.30. And so this is side 32.30. Again, if you don't like the degree minutes seconds, you can keep it as 2.57 when you're doing all this work, and then just make sure that when you give me the angles, you give them in degree minutes seconds. 16, again, drawing my triangle. A is 76 degrees, B is 34, whoopsie, A is 34, B is 21. So the first thing I'm going to do is find angle B because I have the opposite pair of A. So 34 over the sine of 76 degrees is equal to 21 over the sine of B degrees, making sure that I put that degree symbol in my calculator when I do that. When I put that in my calculator, I get 36.8 degrees. Then, so this ends up being 36.8 degrees. Now I'm going to find angle C by taking 180, subtracting 76 plus 36.8. And when I do that, angle C ends up equaling 67.2. Oh, yeah, 0.2 degrees. So this is 67.2 degrees. Now I have to find side C. So using this same proportion, 34 over the sine of 76 degrees is equal to C, little c, over the sine of 67.2 degrees. Putting that in my calculator, I'm going to get C to equal, oh no, 32.3. I got to go back. So this one, if you're wondering, like when I did this one, I got 32.3. Yeah, I was looking at the wrong problem because I have it done. Sitting, looking at my note sheet, I have this done. This one ends up equaling 11.97. Should have done my wrong. I wouldn't have caught it in here. So this is 11.97. So sorry about that. If I could edit, I would, but I can't, so I'm not. So there you go. Numbers 19 through 24, it just wants you to find the area. So when you do the area formula, they're giving me, if this is A, this is B, and this is C. They're telling me A is 5 degrees, 15 minutes. Side B is 4.5, side C is 22. In order to use the area formula, that angle, you have to have the side angle side, which I do. That's how I'm using the area formula, using the sine formula to find the area. If I didn't have that side angle side combination, then I could not do it. I have to do a different formula. which we don't know yet. So to find the area, I'm going to take 1/2 the two sides, so 22 times 4.5, and then I'm going to multiply that all by the sine of my angle, which is the sine of 5 degrees, 15 minutes. And when I put that in my calculator, I get the area to be 4.53, and so this is going to be square units because area is squared. So if it was meters, it would be meters squared. If it was feet, it would be feet squared. And that's all I have to do for the area. Just make sure that you have this side angle side combination. That's what tells you you can use that formula. Okay, now we get into the word problems. Okay, here we go. So what you need to understand is this entire time that we've been in trig, we have always started an angle. This is 0, and we've always gone counterclockwise. That is trig. That's how we live in trig world. Well, out in the real world, when I'm flying planes, not that I really fly planes, it's all based on going north, where north is 0 degrees, and then it goes clockwise, so it goes this way for a positive angle. So when I see a word problem like this, they'll talk about bearings, and this is what a bearing is. So there's two ways that you can do bearings. You can do bearings from directly north. So if I'm doing bearings from directly north, this would be 0 degrees. This would be 90 degrees, positive 90 because you're going clockwise, 180 degrees, 270 degrees, and then all the way back up here would be 360 degrees. That's the way bearings work going north. But then you'll also see things that say like southwest, which means that you're taking the bearing as you go southwest. So you need to know north, south. You kind of need to know that, north, south, east, west. You know north, south, okay, so you know that. So when I have this problem, they tell me a plane flies 500 kilometers with a bearing of 316 degrees. So they're saying with the bearing from here, they go around 316 degrees and they're flying this way. So this is this plane flying this way. And that's, so if this is 316 degrees and all the way around the unit circle, or all the way around a circle is 360 degrees, if I take 360 and subtract 316, I'm left with 44 degrees. And then that's how they get this 44 degrees. And that's how they get this 44 degrees. Okay? That makes sense to me. So I'm going to figure out some things here. If this is 44 degrees, it should make sense that if I'm making this triangle, that this angle here would have to be 46 degrees because they form a right angle. So 44 plus 46 would equal 90. That's how I get 46 degrees. That's pretty simple. And so I fly 5. So I'm going to draw my own little triangle down here. So what I have so far is I have this angle being 46 degrees, and I've gone 500 kilometers. Then it tells me I get to this point here, and I fly 720. So this is 720 kilometers. It says what they want me to do is they want me to find the bearing. So I need to find an angle first, if that makes sense. The only angle based on this triangle that this is a triangle that I have. The only angle that I can find based on this triangle is I have this opposite pair. So I'm going to do 720 over the sine of 46 degrees. I can only find this angle here. So I'm going to go ahead and find that angle, 500 over, what do you want to call this? We'll call this A for lack of anything else to call it. So I'll call it A sine of A degrees. When I put that in and solve or cross multiply, whatever makes you happy, I get A to equal, and it's like 29.97. I'm going to just go ahead and call that 30 degrees. So this angle here ends up being 30 degrees. That's easy. That's not a problem. I hope that's not a problem. So if I do that, then if I have that one angle being 46 degrees, I'm going to, so this is 30 degrees. Then I want to find the bearing. So I want to find the bearing based on north. Now I know that I could add these up and find this whole angle here, but finding that whole angle there really doesn't do me any good. So I'm not even going to bother doing that. I'm going to figure out north. So if I were to figure out north, remember is directly north. which would form a right angle. So if I draw that secondary little triangle, which I'm going to do right here, so this we said was 30 degrees. We're making this north. Okay, I made that one big. This is the 720, but I really don't need to. So if this is 30 degrees, it should make sense to everybody that this is 60 degrees. So this angle here is 60 degrees. So this plane is flying. Here's north. I'm going to just draw like this. This plane is flying. It's flying 60 degrees. The direction it's going is it's going southwest. So I could write it like that because this plane is, because it should make sense to you that if I'm going from here to here, I'm flying southwest, southwest. That makes sense. And the reason why I do southwest first is because I'm taking the angle, I'm doing the south part from here, and then I'm moving west. But if I want to find the bearing, so this is 60 degrees. I'm asking myself, if I start here and go all the way around, so this is 0 degrees, this is 90 degrees, this is 180 degrees, and I have another 60 degrees. So if I take 180 plus 60, I end up with 240 degrees. So the two proper answers you can give is you can give a bearing of south 60 degrees west, or you can give a navigation angle of 240 degrees, and that's a navigation. And I'd like to tell you that you don't need to know this, but you need to know this. So especially if you're going on to pre-calc, oh dear heavens, you need to know this. So that's what bearings means, and that's what a navigation angle means. All right, let's do the next one. So the next one, I have this bridge to be built across the small lake from the gazebo to the dock. So I'm trying to figure out, this is what I'm trying to figure out, is how long that dock is going to be. The bearing from the gazebo to the dock is 41 degrees south, south 41 degrees west. So if I'm drawing this here, this is 41 degrees. And that's how they get that 41 degrees right there. And then it wants to know, and then from the tree 100 meters away, so that's how they get this 100 meters, you have this other angle you have two angles that are given. Is you're looking from the tree to the dock is let me see that, meters. The bearings to the gazebo and the dock are 74 degrees southeast and then 28 degrees southeast. So I'm going to draw a mini version of this while that's even smaller. I don't like that. Let me try this again. So this is 74 degrees, this whole thing. And then going to the dock is only 28 degrees. So if this whole angle is 74 and this little chunk is 28, it should make sense to you. Oh, why did I mess that up? That this angle right here is 78. Oh, no, sorry, 74. 74 minus 28. And this angle in here is going to be 46 degrees. So I'm going to make this triangle. So here I'm going to make and the triangle that I'm making, if you want to know, is this triangle right here. This triangle right here. So what I figured out so far is of that triangle, I figured out that this was 28 degrees. They told me that this was 100 meters. Now I need to find some other stuff because this is what I'm looking for. I'm looking for here. So I need an angle somehow, some way. So then what I did is I said, well, I'll highlight this because I'm trying to make this very simple. That's going north and south. This line is also going north and south. Let me see if I can scooch that over so that I wonder, let's do purple, maybe though. So there's two lines going north and south, so those are parallel lines. Everyone knows that makes sense. And I kind of want to move this line over a little bit. Yeah, right there. Oh, perfect. Then I have cut by transversal. Remember geometry? All coming back to us. Cut by transversal. If this angle here, we were told was 74 degrees. If this angle here is 74 degrees, then everyone knows that this angle here is 74 degrees because they're alternate interior angles. So I have this angle here, 74 degrees. I have this part of the angle here is 41. I have this angle, and this angle that add up to 180. So to find, where's my triangle that I'm making? Let's call this, I called this A before. Let's call this B. So to find angle B, I'm going to say that's 180 degrees minus that 74 plus 41. And when I do all that, I get angle B to be 65 degrees. So this is 65 degrees. If this is 28, no, that's not 28, that's 46. If this is 46, this is 65, then to find angle A, and I have to find angle A because that's the only side that I know, I'm going to take 180, and I'm going to subtract 46 plus 65, and when I do that, angle A ends up being 69 degrees. So this is 69 degrees. Now, once I have that, I'm golden. So I'm going to say 100 meters over 69, the sine of 69 degrees is equal to x over, and then the side angle opposite of x is 46, the sine of 46 degrees. And when I do all that, I get x to be approximately 77 meters. So that dock is going to be 77 meters long. I hope that helps. If you have any questions, let me know, and I will see you next time in class.